As we're joining stuff, we're going to focus on the word and today. And the word and is not called a disjunction. I need you to correct this. The word and is called a conjunction. I don't know why that was done incorrectly, but please correct that right now. So we're talking about the word and understanding the idea of a conjunction. It's where both things happen. It's where they overlap, etc., etc., etc. So I'm going to kind of use some different colors here today. My first equation I'm going to box in red, and I'm going to graph this. So here I'm going to put the number 3, 2, 1, 0. And how do I graph x is less than 3? It's really simple. Open circle, shade to the left. Okay. So everyone do that. Now I'm going to box the x is greater than or equal to negative 1 in blue. Now on the same number line right below it, I'm going to try to keep my positions the same spot. So I'm going to label negative 1 and 3. Greater than or equal to negative 1. How do I shade this one? Luis, give me the first one, someone else. Okay, closed circle. Shaded which way? To the right. Good morning. Hey, freedom. Congratulations. No cast. Very good. All right. Now, here's the idea. When you combine red and blue, what color do you get? Purple. Okay, I don't have purple, so I'm going to use black. Where do these two lines overlap? Where do they overlap? Here's 3. Here's negative 1. Where do they overlap? Where are they both true? Everything that's where? In between. Now, let's look carefully. Are they both true at the number 3? Is this top one true at 3 itself? No. Is the bottom one true at negative 1? Yes. So I have to take this bottom circle and do what with it? I have to fill that in. Because it's true at negative 1, it's true in between, but they're not both true at 3. Does that make sense? They're not both true at 3. They are both true at negative 1. Now here's how you write this as a continuous inequality. You follow your number line and you put negative 1 and 3 with your x in the middle. And think with me, x is what compared to 3? It's less than. Read backwards with me. Negative what? Negative 1 is what compared to x? Look backwards. Negative 1 is, the x is in the middle. Negative 1 is what to x? Less than or equal to. So this is our algebraic answer. Notice both inequalities point left. And the x is in the middle. The higher number's on the right, the lower number's on the left. So the goal here today, Justin, is to understand how do we take two inequalities, graph them on one line, and write them as one inequality. Brett, question?
I thought
negative 1. Where is the negative 1 in comparison to the shaded section? Is it below it or above it? It's below it, right? So that's why we say less than. Think about reading this backwards, Brett. Read this top one backwards. Negative 1 is what? Turn this one around. Less than. So that's another way to think about it. Okay, let's switch back to example 2. The top one in red. Here's negative 2. 0, 1, 2, 3, 4, 5. Shade for me, if you would. Above or below? Haley? Okay, keep it open. Good. Shade to the right. So everyone shade to the right. Put a big arrow. Remember, there's more off the graph than on the graph. Now I'm going to keep the same scale right below it. Here's my 5. Do I fill in my circle? Reviewing for Friday. Do I fill it in?
Yes.
I sure do. And shade to the left. Okay, so our combination. Here's -2, here's 5. Two circles. Are either of them filled in? In other words, is it true for both cases at the number -2? Is it true for both of them? Well, it's not true for the top one, so it can't be true for the answer. But what about here at 5? Is it true for the top one here at 5? Yeah? What about here? So it's got to be filled in there. Where do they cross? Everything that's in the where? In the middle. Now the shading part is the easy part. The graphing, the inequality is actually pretty easy too. The way you set up the inequality, Noah, is you put the lower number on the left, the higher number on the right, the x in the middle. And now we just think through these. Read this backwards for me. -2 is what to x? -2 is less than x. And then read this one normally. X is less than or equal to 5. So here is our answer for both of these. Graphically and algebraically. You have to be able to do both of them. The answer is not the red and the blue. That's kind of the work that leads you to it. John, that makes sense? Okay. Let's take a word illustration and see if we can convert it into kind of an inequality. All numbers that are less than 4, but at least 0. So let's just focus on this part. All numbers that are less than 4. How do I write that? X is what? Less than 4. Okay? But at least 0. X is what? Greater than 0. At least 0. Can it be 0 itself? So do I say greater than 0 or do I say something else? Greater than or equal to. Now, is this a conjunction? Do we want them to be true for both cases? All numbers that are less than 4, but at least 0. What word could you change for but there? You could put the word and in. So let's graph this. Here's 0, 1, 2, 3, 4. Greater than 0. Which way am I going to shade? To the right. Don't go too far. Just kind of start it. And less than 4, which way am I going to shade? To the left. So where are they going to cross? Everything that's in the middle. Do I fill in either circle?
0.
Okay, fill in the 0. Now, let's see if we can write this algebraically. X is in the middle. What's on the bottom? Follow the number line. 0. What's on the top? A 4. Now let's fill in the signs. How does 0 compare to x? Read this backwards up here, what I circle in red. Read that backwards. 0 is what to x? Less than or equal to. And how does x relate to 4? Is less than. Now, look at all three of these answers. What are the inequalities on all three of them? What's the inequalities here? Which one? Aren't they less than? Look here. Aren't they what? Less than? Look down here. When you do a combination inequality, Felipe, they're always less than. Always. So, combining two things into one, translating words into an equation in a graph. So far, so good? Okay. Flip the page.